The dual nature of light as both a particle and a wave, known as wave-particle duality, is one of the fundamental principles of quantum mechanics. This concept was developed through various experiments and theories that demonstrated light's ability to exhibit properties of both waves and particles. And here's how we know that. As far as wave behavior goes, there's a thing called diffraction and interference. Thomas Young's double-slit experiment in 1801 demonstrated that when light passes through two close slits, it creates an interference pattern of dark and light bands on a screen. This pattern is characteristic of wave behavior, as waves from each slit interfere with each other, creating areas of constructive and destructive interference. So what about the particle side of light? There's a thing called the photoelectric effect. In 1905, Albert Einstein explained the photoelectric effect, where light shining on certain materials can eject electrons from the surface of that material. Einstein proposed that light consists of particles or quanta of energy, later called photons, and that each photon's energy is proportional to the light's frequency. This phenomenon could not be explained by treating light solely as a wave, as the effect occurs instantaneously and depends on the light's frequency rather than its intensity. There's also a thing called Compton scattering. In 1923, Arthur Compton observed that when X-rays collide with electrons, they scatter with a change in wavelength. This change in wavelength, known as the Compton shift, could only be explained if light were composed of particles or photons that collide with the electrons. And lastly, and more recently, quantum mechanics and wave-particle duality. Quantum mechanics further developed the concept of wave-particle duality, applying it not just to light, but to matter as well. Experiments have shown that particles, like electrons, exhibit both wave-like and particle-like properties, depending on the experimental setup. And this led to the broader understanding that the behavior of quantum objects, like photons and electrons, cannot be fully described without considering both wave and particle aspects. Wave-particle duality is a cornerstone of modern physics, illustrating the limitations of classical concepts when applied to the quantum realm. It highlights the complex and sometimes counterintuitive nature of the behavior of light and matter at the smallest of scales.